Oh, such a good problem, right? So here's this thing, right? They're basically what we know, okay, is that this thing is pushed up the plane, right, with a velocity of 4.15 meters per second. Right, we know ultimately that it goes like 1.316 meters up the plane, right? Up the plane, right? And then it slides back down, right? And we want to know the time it takes to get back down and its speed when it reaches the bottom. Now, if this were a frictionless plane, we could say it takes twice the time to go up as to go up and down. But that's not true for this. It actually slows down and stops. It's got a much bigger deceleration than it has acceleration down the plane. Okay? And that's because as it slides up the plane, right? Let's just look at a picture of this thing. As it slides up the plane, the force of parallel force is always down the plane, right? And the force of friction is also down the plane, right? So the deceleration of this thing as it goes up the plane, we figured out was negative 6.542, right? Meters per second squared. And we figured that out in, if you want to see how I figured that out, we figured that out in part C, okay? And as it slides down the plane, well, if it's sliding down the plane, parallel force is always down the plane, right? But now the friction force is up the plane, right? And so the acceleration that we figured out down the plane was 1.1, negative 1.12 meters per second squared. And if you want to know how we figured that out, look at part B, okay? We also figured out in part C of this thing that it goes 1.316 meters up this plane, right? Up the plane, right? So basically this is just going to entail two different suvats, right? We're going to do up the plane, down the plane, okay? So hang on to your socks, kiddies. All right, so going up the plane, okay, going up the plane, the initial velocity was 4.15. Final velocity was 0, acceleration was negative 6.542. Right? And we found, we can find the time, right? I'm going to use v equals u plus at to find the time just for fun, right? So 0 equals 4.15 plus negative 6.542 times t. Okay, so 4.15 divided by, and I get 0.64635. I'll say 634 is what it is, right? 6345. 0.634. Oh, it's actually 44 seconds. 6344 seconds, right? Okay. I'm storing that in H just for fun. I've got all these memory registers, right? So that's 0.6344 seconds, right? And then to figure out the displacement, we're gonna figure this out, right? So it's basically that times, I'm gonna use, just for fun, I guess I'll use v squared equals u squared plus 2as, right? So 0 squared is 4.15 squared plus 2 times our negative 6.54 times s, right? Oh boy, that's a mess. Okay, so let's do that. Let's go 4.15 squared divided by 2 divided by that guy. I get 1.316 meters. Okay, so there's part of it, right? Now let's go down, right? Let's suvat down. To go back down, it's got to go down 1.316 meters. The initial velocity will be 0. And let's assume that those little weak chemical bonds that could hold it on the plane don't form, right? And somehow they don't, right? Final velocities we want to know. Acceleration is, and then for down the plane, the acceleration ends up being, let's see if we got that, 1.124 negative, right? meters per second squared. Okay, and then we want to find, I guess, the time and the velocity, right? And the total time will be the sum of these two times. So let's figure this out. How are we going to figure that out? I guess I could use S is 1/2 AT squared, right, to find the time. Right, so T is going to be the square root of 2S over A, right? So it's 2 times negative 1.316 over negative 1.124. And we got these, if you weren't following, right? We got these in the previous parts. I got that from part B. Okay, and the square root is like, this whole thing is square rootular. Okay, so I'm going to go square root of 2 times 1.316 divided by 1.124. Takes 1.53 seconds to get down, right? Okay, so we can answer the question, how much time does it take, right? I'm just going to add these guys together. So plus 0.6344, 2.16 seconds. So 2.2 seconds is how long it takes to get back down, right? It takes less time to stop going up because the deceleration on the way up is greater because both forces are against you, right? And on the way down, it takes a little longer to go back down. Let's see, our final velocity, to find our final velocity, I'm just going to cheat and use this time, right? I'm going to multiply that time by the acceleration, okay? So V is U plus AT. We could use any other kinematic formula. I'm just getting lazy here. So 0 plus negative 1.124 times just this time, 1.53. 1.53 times negative 1.124. And I get negative 1.7129. So the final velocity is 972. There we go. That's meters per second. Okay, so I get that answer there. Notice that we pushed it upward at 4.15 meters per second, and it comes down going slower, and that's because there is friction. It doesn't have the same speed because it lost energy to friction. Go team. Go Timberwolves.